Good morning. On behalf of the entire Windows DNA 2000 development team, I want to welcome you to the Windows DNA 2000 Development Conference featuring SQL Server 2000. Man, that's a lot to get out, a lot of 2000s and DNAs. We very much appreciate you attending the conference. We know it's expensive for you to take time out of your busy schedules and travel and get to the conference and find your hotel, and hopefully you weren't overbooked at the Marriott. I heard there were some problems there, but we welcome all of you. You know, again, we really appreciate you taking the time out and come and learn about Windows DNA and SQL Server. We modeled this event after a conference we did in LA 2 years ago for SQL Server 7 before we launched it. We brought in the development team to do those speak at that event. We got great feedback about the event, great technical content, good technical speakers. We did that. In essence, we're modeling that exact format here today. Only we broadened it out beyond SQL Server. That was our original plan here today, but the feedback we got from you is, yes, we want to learn more about SQL Server 2000, but we also want to learn more about how to build an entire Windows DNA application or a 3-tier distributed internet application. So we've taken, again, the format, good technical speakers that we brought out from Redmond. It's an expensive conference for us as well to pull the developers out of their jobs and bring them here. We do that because of our commitment to you, our most important audience, the developer audience. You are our highest leverage audience, and we very much appreciate you attending, and again, we want this event to be very meaningful to you. So that's me, you got that part. This event and what you do is about building business applications. We understand that. Our job is to build a robust, reliable platform for you to build those applications, and that's our job. We know that you build all kinds of applications, business operations, business intelligence, content indexing, or excuse me, knowledge management. We know that in order for you to be able to build all those different types of applications, we have to understand your business and we have to build a platform that supports all of them. I get a lot of questions from customers, gee, where is your platform focused? Are you focused more on OLTP or transactional or value chain applications? Are you focused more on decision support? Do you even think about knowledge management applications? The answer is yes. We think about all of them, and we know in order to do our job, and in order to enable you to do your job correctly, we have to do our job correctly and build a rich, robust platform that services all of those types of requirements. In the middle of this diagram, the core kind of features and functionality or services that we must provide are the abilities: reliability, availability, scalability, manageability, so on and so forth. Those are what absolutely every application expects. Reliability, the thing it's up, it works, it's predictable. If I do A, it does B. I know it and I understand it. Availability, you want the system always up or up when you want it to be up. Scalability, some of our competitors kind of FUD our scalability, and you'll see a lot of proof points about the work we've done in that area today. And I'm not going to go through the whole list, but leave it to be understood that we absolutely know that this is the core of what we have to do and the services that we have to provide to you. In each and every release, we focus a large percentage of the resources for that release on the core attributes of this functionality. Business operations, your value chain systems, you want them fast, you want them reliable, you want to be able to build them quickly, you want them open. We get that, okay? That's something that the industry's been doing for 30 years. We're working hard on continuing to make it easy for you to get those value chain applications working. Business intelligence, kind of a new market really in the last 10 years. Clickstream analysis with the web could end up being a huge business, might actually be the revenue model for some of the .coms, might be worth more than the actual services that they're providing. We get that. We're working hard and investing tons and tons into making sure that you get good analysis of the data that goes into your systems. Knowledge management, kind of a new kid on the block to core systems management and applications development. Tons of information on the web. You want to be able to search it, get access to it, update it, call tracking, workflow systems. Workflow is kind of an interesting one. We've had the infrastructure to do it for a long time, but we've never really made it easy for you to build those types of applications. So we are focusing, again, a lot of energy and product development in that area. So I'm not going to pontificate too much on this. Many of you have lived through all of these as I have. The point I want to make with this slide is that the evolution to the web or the 3-tier or N-tier architecture is not the first evolution that we've seen in our careers. Each time we have one of these changes in the application architecture, it's leveraging some new technology, in this case the internet. We do better on the things that are good, and we kind of get rid of some of the things that we're not so excited about, and we evolve forward. It's not the end of the world. The first programs, monolithic code, UI, business logic, data access all in one piece of code. Man, you can slap those together easy, IMS, CICS, up and going in no time. But they're difficult as heck to maintain. You know, how many programmers can you get in one program when you're trying to maintain it? It gets messy. We didn't think about interop. You know, there's no interop. Don't worry about APIs. Just get the thing up and going. There's nobody to interoperate with. And they were extremely difficult to scale. When you run out of room on your mainframe, your only choice was to go buy another mainframe. And those systems are still around. Good, solid, you know, well-engineered systems, just not the systems that you're tremendously investing in today, but you're still kind of building around them. Two-tier was a step forward, no question. Rich services provided on the client. Customers loved the flexibility and the prompting and navigation to the clients. They were more open. We paid more attention to APIs. You could write multiple front ends for the same back-end application. Still somewhat difficult to scale because you had that client connecting right into the database server. So your choice was really only maybe split some of the code between the client or the server, or maybe get a bigger server. And again, that can become somewhat scary if you start to run out of headroom in terms of hardware. Difficult to manage. We didn't do a very good job of allowing you to distribute the application to the client. DL hell, you know, just mismatches, versioning problems. It was difficult for you. We haven't given up on that problem. That's a problem that Microsoft needs to solve. We think rich clients will live on. We do believe in mobile disconnected. I think that's a viable marketplace going forward and a big one. So we haven't given up on that. We just know that it's in our court to make that easier to do. The end tier, you know, stateless or loosely coupled. Sure, you've got the client connecting to the bank of mid-tier servers, multiple servers. So you need more connections, you add more servers. That mid-tier server handles all connection or state back to the database, reducing the workload on the database server in the background. So a more scalable architecture, and I've got some pictures and we'll talk more about that. Protocol level interop, instead of an API having to be everywhere, open protocols so that you can discover your data and get access to it directly. I say limited functionality. I mean, you know, think about where we are today in terms of the web. You know, making an order and getting an email back in a couple of days that says, or sooner, that says, yeah, we're pretty sure we're going to ship that, and I hope you get it, and it should be okay, isn't exactly where B2B needs to be, right? Available to promise, you know, priority queuing. Stateless isn't always going to be the only model. So, you know, I think it's good functionality, and certainly the internet economy is moving forward with great speed. But there are going to be more requirements placed on that. If you've been doing probably B2B in your businesses for years through ANSI X12 and, you know, other open formats, and you know that the business requirements get more rigorous as you go forward. So the web, it does affect everything. It puts more pressure right on you. You have to continue to evolve your application architecture. You have to think more openly. You have to think B2B initially, and many of you have to think B to C out to your end customers. WinDNA, many of you may not have known what that meant until you got here, or hopefully you will know that before this week's over. WinDNA is a brand. It's a platform. It's Microsoft's platform for building distributed 3-tier or N-tier applications. On the client, we offer a host of services. We have the leading market share browser in the market today. We certainly have millions and millions of rich client applications in the market developed with our tools, Visual Basic, C++, and others. And we embrace devices of all type, whether they're WinCE or others, all need to be interconnected into this environment through the various protocols of the internet. The application tier, the application server, if you will, something that we shipped with the NT4 option pack several years ago. IIS is an application execution environment or a web server. COM+, as it's known in Windows 2000, MTS previous to that, an environment that helps your application scale and manages persistence of the objects and connection, component pooling. MSMQ, reliable messaging inside the firewall. Our data access stack, ADO is an object model over OLADB or ODBC, accessing SQL Server as well as other databases out there and available. And all of it enabled through XML, and XML parser shipping inside Windows 2000. SQL Server, of course, been shipping in some form or another at Microsoft for just over 10 years now. It's been quite a mature product. The point I'm trying to make here is that WinDNA applications are in the market today. Windows DNA makes up about 25% of all internet sites running today. If you move up the value chain in terms of e-commerce sites, we have 52% market share, I believe, according to Media Metrics. And if you move further up the value chain in terms of business-to-business secure sites, we have 65% market share, according to a Goldman Sachs survey. So this is real technology. People are building real mission-critical applications today, and it's something that we want to brand and make everybody more aware of. The products, as we list them below, Visual Studio 6.0, the most widely deployed and used development tool in the world today. 2/3 of developers use it. Windows 2000 just launched and getting great. I believe there's over 5,000 servers deployed already prior to the launch, and that's increasing rapidly. 7.0, been shipping over a year now. I've got a whole bunch of stats about 7.0. I'm not going to talk too much about it. Site Server, the most widely deployed commerce platform in the market today in terms of sites using the product in the marketplace, and SNA Server for connectivity into your SNA legacy applications. Windows DNA 2000, the next generation of products. Not only do we update the existing products, but also we're going to add several new products to the family, and we've renamed a couple just to keep everybody on their toes. In terms of, we just talked about Windows 2000, and all the components of the application logic or the application server have been updated for some phenomenal scalability, much better use of multi-threading and SMP processors. The IIS ASPs are scaling much better throughput, 2x and beyond in some of the multi-processing environments. Com Plus, again, more scalable, more reliable. MSMQ, a lot of focus on performance. And ADO, much better scalability, or the whole MDAC, or the data access stack, much better scalability in an SMP environment. So, again, that product shipping in the market today. SQL Server 2000, most of my talk is about that, so I'm not going to hit that here. Application Center is a new product. We haven't shipped it yet. There's a beta to come out soon. But that's a product that allows you to take an application, a mid-tier web server, and replicate that entire application to the web farm, to as many servers as you need, and then to manage that as a single application, as a single machine. So that's a very exciting product for those building commerce applications, or actually any application that utilizes a mid-tier. Commerce Server, that's Site Server renamed to Commerce Server 2000. Much more scalable, much personalization, product catalog, business analytics. Had some hard scalability limits that have really been eased, and absolutely should alleviate any scalability concerns that customers had. And then Host Integration Server has been renamed. It was SNA Server. We're branching out the types of transactional support for SNA. We're working on heterogeneous replication, data replication, and a host of other features that we'll use for that product. So that's Windows DNA 2000. You're going to get sick of this slide. We've got it in every presentation, and each speaker is supposed to talk about where their product fits into Windows DNA 2000. But it's just important that we wanted to make sure that you understand Windows DNA 2000, understand the architecture, how the applications are built, and the various products that make it up. So the rest of the talk is about SQL Server 2000. The first slide I put up to, I guess, brag a little bit. We're very proud of what we've done with 7.0 and the momentum it has in the marketplace. I also put it up to state some facts about where we are in the market. And I also, more importantly, put up a pointer to a URL that you can all have access to. When I talk to customers over and over and over again, they say to me, geez, I'm getting killed by the Oracle rep or the IBM rep in my account selling against you guys, and you would give me nothing to sell SQL Server. So we put out on the web on this Fast Facts page, and there will be much more information out here. There will be much more information out here about competitive selling and facts about our product and where we are in the market and those sorts of things from the Microsoft side of the story. In terms of market share, you hear a lot about market share. Oracle leads market share on NT. In terms of unit market share, we have 71% share today. Okay? It is true that IDC quotes Oracle slightly ahead of us in terms of revenue share, but if we have 71% unit share and Oracle is slightly ahead of us in terms of revenue share, I guess that calculates out to one thing, that they charge more for the product, which I don't think is a surprise to anybody in the room. 86% revenue growth, 13 million units. That's more than all competitors combined, I believe. So we're enjoying a lot of success with SQL Server 7.0 and penetration into the market. Easiest to use and manage. I don't have to tell you guys that. You're the loyal and true customers. We've got some studies out there. Customers continually come back when they do these bake-offs between our product and our competitors and tell us that it is an easy-to-use product. I know we can make it better. We're absolutely working on making it better, but it's a fundamental design point for us, and we'll continue to push it hard as we go forward. World record benchmarks, there's a lot of them. I've got slides on that. We'll talk more. Great on the web. Zona Research just came out stating that we've got 68% share of IT web applications. Those are not the .coms per se, but inside the IT shops, the B2B, the intranet apps, our product is extremely heavily used. We also are very active in e-commerce, PC data, media metrics, you pick. The most recent data that we've got, 6 out of the top 10 retail sites for Christmas '99, which is the season for these guys, was based on SQL Server. I think Oracle had 3, and then there was an open source thing was one other. So that's the situation in that marketplace. Those are facts. I try to qualify them as clearly and crisply as I can so that they're not open to a lot of FUD, but we work hard to make sure that we have measurable things that we can say about the product. The business platform, or best platform for business intelligence, out of the box, there's no question that we have the most comprehensive data warehousing product on the market, and it's extremely widely supported. Bill Baker and his team are here from our data warehousing group, and they'll talk more in their talks, but it's absolutely, I believe the last count was over 70 vendors and growing quite rapidly. So we're very proud of the product. We run a lot of rewards. The most important award for us is the fact that you're giving us positive feedback about what we've done. Things we did right and things we need to improve. Competitive features. We don't have every feature. We'll never have every feature. I don't want every feature. I don't want to make the product fat and unwieldy. The key is having the right features, and those are the features that you tell us about, and those are the ones we're getting into the product. Focus on ease of use. Again, a key design point for us. Your valuable DBAs shouldn't have to be out there every day tuning and retuning the same query over and over as the data changes or the histograms change or whatever changes in the database. We should be able to make those adjustments and make the database easy to use so you can redeploy your valuable DBAs on new applications. Quality, I get it. We're working hard on quality. I've got some metrics that we're pushing the product against I'm going to talk more about. We did get good feedback about the upgrade, reliability. There's always more you can do on quality, and we're going to invest a lot in that, and I'm going to talk more about it. The model of scaling from desktop to server, gotten a lot of positive feedback. I don't want to have to rewrite my business application if I have to go mobile disconnected versus the mid-tier server, or excuse me, on a server or up in some sort of cluster, and we'll talk a bit more about that. Data warehousing, the solution-based product and approach, you very much are appreciating that, and we're going to keep pushing that, and you'll see a much richer solution coming from us as we go down the road. And we're listening. I know we can listen more, but every week we've got 5 different customers in Building 1 at Microsoft, which is where the SQL Server development team lives for the most part. Those customers come in and they meet with the development team in the morning. They talk about their applications. They talk about what's going on. And I don't know if you've experienced this, but there's no more powerful experience to a developer than to have a customer sit across the table and look them right in the eye and say, this feature stinks. I hate it. I can't use it. I don't like it. It's an epiphany for the developer. I can scream at them for 6 months to change it. Customer comes in, 30 seconds later, they're running out of there changing the code. So it's a very powerful experience. We've been doing it a lot, and we're going to continue to do it. We believe it's making our products better, and we're certainly learning about how you build applications. Things to improve, reliability and availability. On the platform, you're seeing a lot of that with Windows 2000. It's a huge focus for the development of that product, and SQL Server 2000 and beyond. You'll see more, and I'll talk about it. Scalability. I'm worried if I'm on this platform that I'll run out of headroom, and then what do I do? Do I have to rewrite my application? Geez, that really scares me. What am I doing to help you there? And we're going to talk an awful lot about scalability in this presentation. XML and internet and making sure that we have great connectivity to SQL Server. We absolutely have that. And then again, more integration and data warehousing. So the points I'm going to hit, and I'm going to have to kind of push through some of these slides. But the high points of SQL Server 2000 are scalability and availability. It was a huge investment for us, and you've seen some of the early returns of that already at the Windows 2000 launch. I'm going to talk about how we did that. Internet and XML, it's a key focus for us. We want the product to be great for everybody on the internet. Data warehousing, I have a whole entire team focused and thinks about nothing but making SQL Server a great product for data warehousing and business information and business analytics, and lots of new features throughout the product. Again, I hope they're the right features, and quality throughout. So it's scalability. I'm going to talk a little bit about some futures here and some philosophy and design goals and what goes on in database. I hope we'll get a little education out of this. There are basically two design philosophies or architectures, if you will, for database systems. You can do scale up or shared everything architecture. This is the SMP machine, the big one box, plow all your engineering into making sure that you're getting good cache location and making sure that you're not having a lot of sharing between CPUs so that you can really scale the best you can in an SMP environment. There's also scale out, which means you take multiple servers and you have them work together as a single system image, and your increment of scale is not having to buy one whole new machine, but you continue to add machines to that architecture and then scale out as you have the requirement. We're going to talk about the pros and cons of both of those. Shared everything is tried and true. It's been around forever. It's implemented by virtually every database vendor in the world. The idea, as I said before, is it's a single node. And the concept design point of it is that any CPU can access any memory or any disk. So everybody's got access to everything, okay? We work really hard on parallelizing SMP machines, okay? We read about parallel query, parallel create index, parallel utilities. What we're doing in those things is that we're taking all the processes that we can and we spread them out and run them across the processors that are available, okay? So for instance, on a query, we can do sorting in parallel, we can do filtering in parallel, we can do aggregation in parallel, but eventually you get to a point where you can't do something in parallel, and we'll talk more about what happens in a minute. The pros to this kind of approach are just flat out simplicity. It's one machine, it's easier to manage, it's sitting there, you can touch it, you know what to do with it, and it's easy to do. The con is it's a single point of everything, right? Single point of failure, yeah, you can do disk mirroring and you can get a hot backup, but that stuff's expensive because it's got to be in essence of enough capacity to have the full system image on it if it fails. Scale, again, you have to buy the whole machine and the upgrade can be quite expensive. But the real killer is the fact that you will bottleneck on shared resources, and over time you just don't get the investment in the machine back out of it, and that varies tremendously based on your application. This graph is not a scientific graph. It just shows that transactions per minute do fall off as you scale out in terms of the number of processors. This doesn't work the same for any two given workloads that are different. The reality is you just don't know exactly when it's going to happen, and you can do a lot of tuning, but eventually the reality is that it does happen. Eventually, no matter how much we parallelize, somebody's got to go take a lock or do an I/O, and at those points you're going to serialize, and at that point your performance is going to fall off. So the key point here is increasing the speed of the processor, and the number of the processors does eventually result in some diminishing returns. And to the point, I just picked a couple of TPCC results. I picked our top result that we just shipped or we just made available on an SMP machine. This is on an 8-way Unisys machine. About 20% improvement over 7.0, very nice number. And then I took this top SMP machine, it's actually not the top number is 135, but I took a 115 number on a Sun machine at 105 TPMC. The big Sun Oracle number is a very impressive number, 115,000 transactions a minute, but this is a 64 proc machine, and this is an 8 proc machine. So 8 times more CPUs to get 2.3 times throughput. So on the CPU or on the TPCC workload, you're seeing that curve flatten out in a big way as you go out to more CPUs. We're delivering 3.3 times more transactions per CPU. And the big killer here, and the reason why it becomes pretty intuitively obvious why our competitors say we don't scale, is cost. They're protecting some pretty impressive margins above where we are in the SMP market space today. So, I guess you could call this scalability, but it comes at a pretty hefty price. And again, it's a pretty scary scalability because you never really know in your application where you're going to start hitting the elbow of that curve. But scale up is important, and we work hard at it too. These are some interesting SAP benchmarks. Again, comparative hardware. These are all 8-way machines. Oops. This is our 7.0 number with 4,500 concurrent users on an SD benchmark for SAP. This is an Oracle number. I don't know what happened to the label here, but it's an Oracle number on NT4. That was the top number on NT until we just published this number at the Windows 2000 launch. Again, this is absolutely the same hardware, just came through hard engineering. We got some important enhancements because of high-speed network connectivity, GigaNet, ServerNet, and those kinds of technologies. About a 10% boost there, but the rest of it came just from hard engineering. So to make this point, 37% more scalable in the SMP configuration on comparable hardware against Oracle. And we're working real hard with SAP. We've got great market share with those guys. And SAP has now made an unqualified statement as of the Windows 2000 launch that we can handle any SAP customer in the world on the NT SQL Server platform. Now I want to talk about shared nothing or scale out. Multiple nodes working as a single system image. That's what we talked about before, and that's the definition in essence of a shared nothing architecture. Again, you see each machine, memory, CPU, disk, table 1 across all 3 of these nodes. This is one table. Let's say it's some sort of personalization table where you're using range partitioning on the name, ABC names here, DEF here, and so on. Again, one table, but to the end user, this is a single table, and they don't understand or realize or don't care it's spread across n number of machines. The pros in this architecture is it's tremendously scalable, which I'm going to show you in a minute. And the increments of scale are very economical. You add another machine, you add another machine. You have to keep spreading out your data, so there is some overhead for you in doing that, but the architecture is inherently and fundamentally extremely scalable and very flexible. You can do all kinds of things, like if you have a name table, small name table that you're constantly having to join to get the name of your customer, you can replicate that name and keep it on each node so that you're not constantly having to jump across and pick up all the network overhead and going across to the various machines. It's tremendously powerful in what you can do with the architecture. It's a proven architecture. Tandem's had it for years. Teradata had it in decision support environments, not really in OLTP. Informix has some form of it, mostly for decision support. IBM supports some form of it, again, mostly for decision support. But it works, it's proven, and it does have great scalability, although it's not as, it hasn't been invested in as heavily by some of the other vendors as the shared everything has been in the past. The trade-off is complexity in terms of management, and we'll talk a bit more about that in a minute. So here, with shared nothing, the affinity is by node. You don't have node A going after records on node B. What you do is you ship a function to node B and you tell node B to go get it. That way you don't get serialization behind these critical resources. So you're getting a much better scalability line on the shared nothing architecture as opposed to the shared everything, which we've had the proof point before. I throw a shared disk in because that's kind of a hybrid that Oracle sells today. It doesn't really go all the way on either side. In essence, you can have CPU memory, CPU memory, CPU memory on multiple nodes, but they all serialize through something called the distributed lock manager, which accesses a single disk. So no single node owns data. They all share the data together, and they serialize behind this distributed lock manager or any kind of I/O, and that's why they get a bit of a fall off in terms of throughput. And to that point, we're very proud of our TPCC results that we published with the Windows 2000 launch. These previous numbers, these are on Oracle shared disk cluster, 97, 98, and 99. Good scalability, but you see it's starting to slow here in terms of what they're able to get in terms of throughput. And then, so this is a 96 CPU configuration, 4 24 by SMP machines. This is 8 by machines, so this is 64 procs, so you're talking about less hardware, tremendously less cost, and greater throughput. And we got that number, I don't know, several days before the Windows 2000 launch, and we were all slapping ourselves on the back and so psyched up about the accomplishment that we'd made. And then we thought, what the hell? We got some more time. Let's throw 4 more nodes on and see what we can do. So Compaq, a great partner in this effort, worked with us, and we configured 4 more nodes into the system and jumped up. So now it's 96 CPUs versus 96 CPUs. Shared disk architecture, shared nothing architecture. Okay? Put 4 more on, they got 19,000 TPMC per node, and we jumped it up to 227. This number got audited at 4 a.m. When Bill was on stage at 9:30 a.m. that morning. So we worked it right up until the last minute, but again, great results, absolutely proving, what we had thought would happen in terms of scalability and what the industry, hadn't actually known for years, and also at a very reasonable price point. So we're very proud, and this is scalability. This is a scalability model that's been proven on the web. If you look at all web, thank you. That feels good. We worked hard on that. A lot of sleepless nights on that one. It's a proven model in terms of how applications are built today. It's not just web applications. SAP, PeopleSoft, Vaughn, others also pursue kind of the mid-tier or this 3-tier scalable model where you have an application server in the middle making connections back to the database server. So application servers, you need more connections to the database or to the application. You clone your application server and you add it to the configuration. Kind of this clone and go. Very economical. You can do it with 1 proc, 2 proc machines. We see a lot of the .coms doing it with $2,000, almost what you think of as desktop machines, and really getting great scalability out of it. The problem is over time, this becomes very difficult to manage if you get tens or dozens of these, dozens of these application servers. And then on the back end, you've got this single shared everything database machine that really is the single point of failure, single point of scalability. It can get very expensive on the Unix platform, sometimes costing 10 times that of the commodity 4 and 8-byte machines. Failure containment, limited to disk. If the server fails, the whole thing fails. Yes, you can fail it over, but you've got to have the exact same hardware duplicated. And overall, it just becomes a kind of an expensive and scary experience because you don't exactly know, based on the workload of your application, where that elbow is going to occur, and you're going to start hitting the serialization bottlenecks. In terms of our approach to the Windows DNA 2000 and the features that we pushed both into SQL Server and into the Windows into Windows 2000, we want to enable the same approach that has been so successful on the mid-tier to the back-end database server. Now, we don't have all the problems solved back here. A full shared nothing implementation takes years to implement, but we have made a very, very important step, and it's a step that we didn't think we'd be able to make until our Yukon release. But we worked hard on it, and we put it in Shiloh. Shiloh is SQL Server 2000. We had about 4 guys that were just absolutely committed to making this happen and been working on it since last summer, and really pushed and pushed and pushed and made it happen. And we're very proud of what they accomplished, and that is what gave us the award-winning TPC benchmarks. But things that we want to do to enable this configuration in a more manageable and scalable way going forward. I talked before about Application Center 2000, a great new product that will be coming out later this year. It allows you to manage your web farms. Again, exact cloning. I've got replication instance on this machine. I want to clone it to the next machine, to the next machine, to the next machine, and then manage those as a single instance or a single system image. That's Application Center 2000. We want to take the success that model has shown in the application server and move it back to the database server. And that's the idea with this feature called partition views. They scale extremely well. We've proven that on the TPC-C workload. How it scales on your workload, again, we have to see. But overall, it's the most tunable, most economically reliable and scalable solution, we believe, in the marketplace, and we're going to pursue it very aggressively. It will have increased management overhead. While we have delivered transparency for query, insert, update, with SQL Server 2000, we will not deliver single system image for management. So you'll have to do create table on each node, create database on each node. You have to back up each node. We'll provide you some utilities to help make that easier. We'll provide you utilities to copy the database from one instance to the next, but it doesn't have the full implementation. I know customers are going to use this. We've got .com customers using it actively today without the transparency built in. So it's an important first step. I'm not at all saying we're done. I'm saying it's an important first step, and we're going to work like hell to make it easier, because I believe firmly that it's the right model for scalability for your businesses and your customers. So scale-up features, a lot of memory support. It's not only greater memory support with Windows 2000 as it ships today, it's also the 64-bit version that will follow on when NT ships NT64. We've also, and continue to do, we've got a great developer, a guy named Eric Christensen, that works very hard on the shared everything work to make sure that we get good cache locality, meaning that you don't have to have a lot of shared data structures in the various processors in an SMP environment, and that creates a lot of overhead if you have that. So the number like the big SAP advance we had in the shared everything architecture, that comes from doing those little tuning to the engine to really help you get the best leverage out of those machines. You don't want to tune it too far, because you start to maybe knock off some of the lower end requirements, but it is some tuning that we do pursue and pursue actively. Partition view support, that's the shared nothing approach that I talked about. We're going to work very hard on keeping that moving forward. SQL Server 2000 first installment, Yukon, which I'll talk a little bit about at the very end of my talk, is the next big installment. And then general scalability, parallel create index, 6 times faster on a comparable machine between 7.0 and SQL Server 2000 on a comparable 8-way. So this is a big boost for all of you out there with the bigger hardware that won't need to have big tables. Index views, you may have heard of this as materialized views, the ability to aggregate or join or filter, run a query that does those functions, materialize the answer set, and then the optimizer can reroute other queries that are going against the base tables over to that indexed view and get tremendous response time gains for queries that fall into that category. Indexes on computed columns, great for geospatial, Z-transform, any kind of calculation you want to make, you store it as a column and you can index it. And in SuperScan, we've doubled our maximum I/O throughput rates to be able to keep up with the latest hardware. Again, giving us tremendous benefit. Merry-go-round scan just means that if you've got multiple scans going, the second through n jump on to any currently going scan so that you leverage the same I/O that's already taken place. So lots and lots of features in terms of scalability. Proof points, world record TPCC, we're proud of it, we worked hard on it. SAP retail, 3.1 million line items per hour. That's the new retail module from SAP, back-ended by the SD benchmark. PeopleSoft, financials, HR, again, these are benchmarks that are unrivaled by any competitor on any platform today, proving that we're pushing NT and SQL Server, and honestly, Com+, IIS, all of those technologies. The interesting thing that I forgot to mention previously is that the TPCC numbers, a year ago we used Tuxedo as our transaction monitor in our TPCC results, because we were always after the biggest number. We're trying to show off SQL Server. Today, in our world record TPC benchmark was used with Windows 2000, all Com+, IIS components. So that architecture has really come a long way in terms of scalability and throughput. World records on NT, you can read the list. Again, we'll continue to push this stuff and make sure that our platform scales higher and higher in the marketplace. One thing I should mention, through a joint venture between Unisys and Compaq, we will be seeing 16-way SMP machines and 32-way SMP machines, I think later this year. So that will, again, boost our shared everything story one notch further. So we're very excited about that. So to recap, in terms of scalability, shared everything, great architecture, everybody does it. I'm sure all of you do it today, but you get diminished returns on hardware because you do hit this point of serialization where the line flattens out. Shared nothing, partition resources scale extremely well. Pedro Celis, the chief architect of Tandem, who built that technology at Tandem, Jim Gray, who helped engineer that technology at Tandem and then Informix, all working at Microsoft now. We have a team built, deployed, moving, writing code today for a full shared nothing implementation for Yukon. So we're working very hard on this technology, and I'm very bullish on it in terms of what it can do for your business in terms of scalability at a reasonable cost. Challenge, make it easy, and that's what these guys are excited about. They've done it before, they know how to do it, but we need to do it in a SQL Server way, or a way that allows you to deploy it and hands-off. We need to provide a tuning wizard so that you know which tables and how to partition. All of those things are our challenge. Our future, we're going to continue to invest like heck in shared everything. We know it's important to your business, and we know, quite honestly, for most applications, it's just fine. We also know that unless we do shared nothing, you'll be scared to really go with this on your big applications on shared everything, because at some point you're going to run out of gas. And quite honestly, it's a better model for scalability because you can scale in increments of cost to your business that are reasonable and understandable, and you can make bets on a given technology in reasonable increments without having to spend millions and millions of dollars on a machine that you may not ever use all the capacity of for a single application. So that was scalability up. Now we got scalability down to the Windows CE device. We are working hard on a team to build with a team in the SQL Server business unit to build a robust engine to scale down to the CE. It's not the same engine that runs on the server on the Win32 and Win64 environments. It's just too hard to get that code to scale down to that small footprint. It is some of the code. We do want absolute compatibility between the SQL syntax between Windows CE engine and the engine on the other platforms. So we did take a lot of the parsing code, and we've taken as much code as we can, but we really are putting together a new engine. But the design point for that engine is a full, robust SQL engine for the features that make sense. You know, multi-user on a CE device isn't exactly something you need. So there's a bunch of things that you just don't need in that environment. But we have done a tremendous amount of engineering. This will ship in the Shiloh timeframe, probably slightly after the RTM to the SQL Server 2000 full product, and more aligned with the Windows CE releases. The good news here, again, the SQL's the same, ANSI syntax, compatible with SQL Server 2000. Great bidirectional merge replication. I believe Deborah Dove and Kevin Collins are here to talk about that. Ron Sukup will talk about SQL Server or replication from the server side. But again, really important to have good replication between the products on the devices and the server. And then other connectivity models where you can just connect as a client and then connect as a disconnected client without the engine, just having some local cache. And again, design point, hands off, and absolutely using the tools that you're familiar with from the full server environment. So that's the end of scalability. You can see a tremendous amount of engineering and effort went into the various scalability breakthroughs. Availability is the next big piece. And again, I'm going through a set of feature slides now. I'm going to move more quickly through these because there are many talks over the next few days. I kind of want to use these as kind of ticklers to get you, thinking about maybe I should go to that talk or maybe I shouldn't. And I don't know the numbers. I apologize for the talks. I actually wanted to put them on my slides. But I know the guy's talking, so you'll have to look at the speaker name and kind of trace back there and see if this is a talk you want to go to. Availability, we want to make sure that you can leave the server up all the time. I mean, the ultimate goal is that to apply a service pack or an upgrade, you don't need to take the server down. To create an index, data is always available. All those things are design points, and we're working very hard. You've seen all the engineering we put into backup in 7.0, and we continue that here. You've seen our online consistency checker. Now we've gone forth in this release and put in an online reorg, which allows you to take your fragmented tables over time, both at the index and the data page level, and run a reorg while the system's online with a minimal 20% throughput impact. We're actually pretty impressed by that, and we'll continue to work and get it down. So there should be some point in the day at any time where you can, you've got less throughput. You could run an online reorg if you have absolute availability requirements for that system and take a little hit on throughput, but yet keep the system up and available. Improve failover. I don't want to say, it just works, but it very much is set up to be point, click through the setup, much better, more robust implementation, and much better integrated with NT Windows 2000. Full text search, which is now cluster aware and supports clustering. That was a big request from our customers. And we also support the 4-node active-active clustering. We've integrated in log shipping to the product. It's a form of availability. You might ask, how does that compare to the failover clustering? Greg Smith, I think, and Richard Waymeyer also have talks about this here, and you can learn much more about those technologies there. Faster differential backup, we keep a bitmap of any page that's been touched in the entire table. So if you've got a terabyte database, or in order to back it up, we know exactly which pages have been updated, and we can go directly to those much faster. Serverless hardware backup, if you've got hardware mirroring from some of the more advanced hardware vendors, you can break the mirror and take a flat file backup and then reestablish the mirror, and the hardware and software will catch the mirrored copy back up. That's the ultimate in availability in terms of disk. And then application point and time recovery, we've added a feature to allow you to put a mark on the log. Started payroll checks here, started batch process A here. So if you want to do a big point in time recovery at the application level for some application level corruption, you can do that much easier. So as you can see, lots of work in terms of availability. Programmability, the #1 requested feature for as long as I've been associated with SQL Server has been cascading referential actions. They're in, they work for updates as well as deletes. It just eases your programmability. User-defined functions for T-SQL, you bet. In this release, they work on scalar as well as table-valued functions. Instead of triggers, think of this as a before trigger, allowing you to do any arbitrary logic. You can put code in here to update arbitrarily complex views, or actually work on inheritance in this kind of a function. And again, fires before the event you set the trigger up on. Order triggering for after triggers, you can actually determine the order of the trigger. Lots of new data types. And one thing that we don't always talk about, but I know is important to all of you, is documentation. We've rewritten 3 sections, ground up, replication, DTS, and the failover. We needed better documentation there. And we've also put in this cool online links, so you can give us feedback online over the web, and then as we update our docs with your feedback, we can push that back into your documentation so you have it. Query Analyzer, Gert Drapers, I think is going to come out and talk about the tools in a few minutes after a break. We've integrated a T-SQL debugger inside the Query Analyzer, so that becomes your tool for development of all your stored procedure work. Statement tracking, think of it as a mini profiler following the events per statement so that you can find out how things are executing inside your stored procedure. This performance profiler is very cool, allows you to track activity all the way from the client to the server, and then back to the client, seeing all kinds of activity based on the kinds of things that you want to track. And the index tuning wizard has been integrated into the query analyzer so that you can take any recommendation actions and paste them right in and make any changes to the environment that you'd like. Index views and computed columns are also recognized by the query analyzer. Data replication, a big release for replication. Transactional replication has been DTS enabled, so you can do data transformations against the data that you're about to replicate before it gets replicated out to your environment. A very powerful feature. Queued replication, transactional replication for mobile disconnected customers or periodically disconnected servers. Again, providing transaction level support for that environment. And much improved snapshot concurrency. We do kind of a 2-pass where we don't take any share locks when we're doing the initial pass to get the snapshot, and then we go back and fix it up so it's transactionally consistent from the log. So much better concurrency when the snapshot is taken. Merge is much faster, 2 times is a safe bet, server to server. Ron and his team did a lot of work to make things much faster in terms of multi-threading, server to server. Lots of new conflict resolvers. A big feature request was add and drop column schema. Many customers were frustrated on how they had to break down, resubscribe after any kind of change was made to the schema. And now you can do add and drop column for schema replication, both for transactional and merge. And this is a concept of an attach and go subscriber. If you mail someone a database, you detach a database, mail it to somebody, and they attach it. If there was a subscription with that database, you're automatically subscribed in that environment, and you can get replication. And there's a heck of a lot more. Again, Ron Sukup and his team are here, and they can tell you a lot about the features there. Manageability, a lot of integration with Windows 2000, WMI being the first, making available standard schemas so that you can plug in and get more information about standard management events. This concept of being able to copy a database, lots of customers have asked for it. Geez, I want to take my test environment, I want to copy it to my production server. Or I'm trying to do some server consolidation, I want to copy this database and all its attributes over to this server. We've put that in the product and getting a lot of early positive feedback on it. Log shipping provides one to more warm standby servers. They don't have to be geographically co-located, which is kind of the difference between the Wolfpack or failover solution. And it absolutely captures all log events, so it's a guaranteed 100% consistent copy of the database. The backup servers can be promoted to the primary in such an event as a failure, or you can use the backup servers as querying servers or hygiene servers or whatever you'd like. And all tools in this release are 100% failover aware. So that's kind of the run through scalability and availability. I'm going to talk for a few minutes on the internet and some of the XML technologies we put in the product, and then we're going to touch on data warehousing, and then we'll end it. Application hosting, big market coming. And also something that comes up quite often. Geez, I want to consolidate some servers. I've got this new 8-way, and I'd like to take the app off that 4-way, the app off that 4-way, and the app off that 2-way, and potentially merge them. There's two ways to do that in SQL Server. We've always had the ability to have multiple databases per server, okay? But we had some restrictions that made it kind of cumbersome. The biggest one was you had to have the same code page and sort order. Okay, that was a big restriction because sometimes SAP uses this code page and your app uses this code page, and you really couldn't do that. But we've eliminated that restriction. We've got column level correlation sequencing now, so you can absolutely mix code pages, not only by database, but even within a database and a table at a column level. So that restriction has been lifted. So this becomes a very powerful model, and I believe the most powerful model for conserving system resources, because having one server with multiple applications allows you to really share the machine in the most leveraged way. The other opportunity is a feature we've added, which is multi-instancing, the ability to run multiple physical SQL servers on the same machine. You do consume more hardware in this kind of a configuration, but you can run, for instance, a 6.5 or a 7.0 server with an 8.0 or a SQL Server 2000 server on the same machine. You can't have multiple 6.5 and multiple 7.0s because we don't support multiple instancing in those releases, but you could have one 7.0 with multiple 2Ks. You could have one 6.5 with multiple 2Ks. Great for upgrade, migration, that sort of thing. And also kind of important for some of the application hosting vendors who really have to have guaranteed levels of service for specific applications. So that's an important new feature. It's really hot on the desktop. What we found out is for MSDE down on the desktop is that that really isn't a server environment, and customers don't want to share, and they wanted a copy of MSDE for their app, and they didn't want any other app to be monkeying with it, and that works very well in that environment. In terms of XML, XML is something that we believe in deeply. We're working hard. I've got a team focused on it. We're participating in the standards committees and working with competitors to come to some agreements on various XML protocol and schema and that sort of thing. But in SQL Server 2000, we will enable URL access through HTTP into the server. You actually connect through HTTP to an ISAPI DLL in IIS that we provide, and then we make the connection into SQL Server. In a future release, we will plumb HTTP, I believe, directly into the server, but this does give you the feature. It works well. We're getting good performance through it, and it will allow you to have a URL that somebody can click on and take you right in, execute a query, and provide the result set. Annotated schema is a way to get an XML map of the database, an XML view of the database. It's a way for you to define how you're going to retrieve and persist XML schemas onto the relational schema in the database. You will be able to retrieve data in XML and store data in XML and SQL Server 2000. For the SQL developer, the guy who likes to write SQL, you just add 4 XML clause in your SQL statement, and your result set will come back formatted properly with the XML. The XPath, or the XML developer, we have this XPath solution that allows the XML developer to actually query via the XML view of the database, and that's supported through this concept of an annotated schema. So the annotated schema maps the XML, how it looks when it's down, stored in the database, and the XML developer can query, in essence, that annotated schema, which allows them to query the data in an XML type format. You can utilize XSL and XSLT to do transformations, further transformations, reports, HTML, whatever you'd like, formatting after you get the data back. And for storing data, OpenXML allows T-SQL developers to actually go and persist XML column tag data into the database and then update grams. And update gram is actually going to ship slightly after. It'll be a web release slightly after the product ships, and allows you to do updates directly against the XML utilizing sophisticated annotated schema. So again, this is first installment here. We'll continue to revise. The XML team has got this concept of web releases, and we are releasing these things pretty quickly out of band with the server on the web. You can download them and utilize them. I wish I had that URL, but I'm sure it'll be provided many times throughout the next couple of days. Full text search, a popular feature. I hear a lot about it. We worked hard on performance. There's some impressive numbers ranging from 9 times in performance improvements on some of the incremental update work. And full crawls have improved, again, depending on your application, 10 to 30%. Change tracking is a new way to keep the index up to date, which provides near real-time update of your content index. And then content filters for Excel, Word, virtually any file type can be filtered and then queried directly. So you can write, query syntax against a Word document, resumes, whatever. Security, always important. We have implemented an auditing solution, both to get C2 certification and because we do have a sophisticated set of customers that do require auditing from time to time. We've made the product more secure out of the box. That means our default security is integrated security. And if you're going to go with standard security, there's a checkbox that says, geez, please don't leave the SA password blank. That's a bad idea. And if you do, don't call me when things go bad. So we just have kind of one little check mark there to make sure you really know what you're doing. If you're setting up a test server or something, fine. But we have had customers do that on the web and they call and blame me. It's kind of hard to take that. Encryption, strong encryption, both log on and you can set it up for data, Kerberos with delegation through the Windows 2000. Now I'm going to talk about data warehousing. Data warehouse can be a daunting thing. A lot of technology, a lot of pieces of, a lot of expense necessary to go into it. You've got to pull data from many different heterogeneous sources. You've got to put it into some sort of cleansing mode. Maybe you do an operational store, maybe you don't. Maybe you cleanse it and put it right into your normalized data warehouse in a star schema. Maybe you pump it out to data marts, maybe you don't. And then you've got all these different types of analysis you can do. And boy, if you know what you're doing, you better keep a roadmap of where in the heck all this data is coming and going to and from, or if not, you're going to be, trying to answer questions like, well, I'm sorry the two sales numbers don't reconcile. They should reconcile. So, this can be a kind of a daunting environment. We are working hard. We did in 7.0, and we are in 2000 as well, working hard to provide a complete solution here out of the box. OLADB and XML enabled transformation of data into SQL Server utilizing DTS, our ability to then take that information and store it either in the server, SQL Server itself, the Relational Database Management System, or in the OLAP service, the ability to splice out cubes and push them around your organization to keep the data close so you can get good analysis out in the field, and an open set of APIs to make sure that a host of third-party developers and tools can plug in and get access to all this information that's stored. All supported through our metadata services, which is a series of schema that we update and keep track of, that you can update, that you can query, so that you know where the data is, you understand the lineage of your data, you know when it was transformed, you know what rules were applied, you know where it is, and you can get access to it. I am going to talk now about some of the features that we've added in the OLAP service and in the data mining technology. OLAP has been a runaway for us. It's really done extremely well in the V1. Gotten a lot of customer feedback and a lot of customer usage. Some of the feedback that we're responding to in SQL Server 2000 is the finer level granularity of security, cell, and number level, much more complex dimension handling, greater flexibility for ragged hierarchy. We had some scalability limits of 64,000 in twin chain. We've in the parent-child twin chain, we've eliminated that with 100 million row plus. Very scalable, and then support distinct count and slowly changing dimensions. Multi-server support, this is very similar to distributed partition views that we did for the TPCC result. The OLAP technology has the same feature. And internet support, again, you can do an HTTP connection directly in, you can get URL access, web deployment, a much lighter weight client that can be downloaded and utilized locally for the local cache. And then again, really focusing this technology on this up-and-coming clickstream analysis, this massive data that floods in based on the analysis on you as you navigate your way through the websites on Saturday morning, and as your children do, and what facilitates mailings, and all the analysis that goes into making sure that people can do great personalization of your web experience. That data goes somewhere, and we want it to be in SQL Server, and we want to enable all the technology so you can use SQL Server to get those answers. Data mining, we will ship some data mining technology, 2 important new algorithms. We work closely with Microsoft Research. Usama Fayyad, kind of a thought leader in research in this area, has helped us tremendously. We've had Microsoft Research developers working with us to implement this technology. Data mining is not the easiest thing to explain. Bill Baker and his team are here, and they're going to give you a much better definition than I. But you think of model-driven analysis, or OLAP, whereas you understand the schema, you understand the questions that you're going to ask, and you format the data and the schema in that way, and then you do your analysis. Data analysis, you don't always know the question you want to ask. You're looking for patterns in the data. You want to know a clustering of what kinds of clusters are stored inside your data. You know, do people that do A and B also do C? Those kinds of analysis. And that's what's enabled through data mining. The 2 core algorithms that we've implemented are I talked about clustering, where you're looking for, you know, groupings of people that are 30 years old that live in San Francisco that make over $75,000 a year, always drive a BMW, right? You know, those kinds of clusters. Classification is more of a decision tree type analogy. You kind of define the algorithm of how you think the decision tree is going to go. The data flows through that, and then you start to see patterns in the data based on it. Again, I don't do justice to this stuff. It's complicated. It's complicated at the implementation algorithm level. It's actually quite powerful and easy to use at the end user level. We'll continue to expand OLADB for data mining to make sure that we have good, solid, standardized APIs for you can plug into this technology, and I think you will find it interesting. Tight integration with SQL Server. We want all this technology to work in the SQL Server family of products, and I talked about our relationship with Microsoft Research. Gert Drapers is going to come out in a few minutes on this stage and actually make a presentation about the tools, and I'm sure data transformation services will be one of them. We have done a lot of engineering work to make the DTS pump restartable, allow you to have multiple steps, restartable within a step, outside a step, aggregation. We've enabled primary foreign key and constraints to be imported in through some of the competing products, and then enabled a much better programmability model for DTS. So closed loop analysis is this concept of taking your data warehouse and then doing analysis however you need to do it, and then going back and acting and getting something done in your business because of as a result of your experience. You know, whether that's going back and changing pricing to your online systems, whether it's going back and doing a targeted mailing from your data warehouse or one of your operational stores. This is the model of what we're trying to achieve with this Microsoft SQL Server 2000 and beyond data warehousing technology, and we're working very hard to make sure it's a complete solution for you. So now I'm kind of winding up here. Commitment to quality. This has really caught on. The team is absolutely driven to make every release better. And I've just listed some kind of quantifiable things here that we're doing. These are the SQL Server 7 kind of test suite and release criteria and things that we did. And here's what we're doing in 2000. You can see in every category we've bumped it. Functional tests, way up. These are the tests that cover all functionality in the product. In essence, get run almost every night to make sure that we're getting a good build out on a regular basis. Stress tests, whether they're our own or whether they're ones that you've provided us through these playback capture mechanism. We've got about 130 customer playbacks that we run now to make sure that the product is testing and stressing well. Long haul stress, just about 30 different customer applications. We bring them up on the server, we run them, and we just let them go and see how long they go. Finds all kinds of subtle memory leaks, either in our technology, SQL Server, or in NT, or whoever else is in the configuration. Don't know how long that's going to run. 63 days and counting last time I looked. The idea is that it should run forever, and that's our target on that. You find all kinds of very subtle bugs and interactions that I'd rather be finding and fixing than having you find, because it's very expensive to find them in your environment because the repros on them can be very difficult. Internal EAP, early adopters programs. The poor ITG guys at Microsoft, you think you have it tough. We put those guys through hell. We make them take early builds, and we make them put them in production, and we learn a lot. We've got over 17 applications in production at Microsoft today with beta 1 of SQL Server 2000. Before we ship, we'll have over 40, and Microsoft will be running its entire business on SQL Server 2000 prior to RTM. External EAPs, this is when we grab customers and we work with them closely and we make sure that they put the product in production, sometimes 3 to 6 months before we release the product. I have found through my experience that the way you really know where you're at is to make sure that that product is running in external customer sites in production and has for a number of weeks before you can release a really high quality product. Beta 1, we released to over 1,000 customers already. Beta 2 is on track to release very soon, the next couple of months, and that'll be going out to probably hundreds of thousands of customers. That'll be a very broad beta. So, in summary, scalability and availability, you bet. Device, it used to be desktop to cluster, device to cluster. We want to make sure that we cover the entire spectrum of platforms that you want to target for your applications. Benchmarks, they're proof points. We know the customers, follow the proof points, so we work hard to make sure that we're engineering the scalability. I honestly wouldn't do benchmarks if it wasn't creating good engineering discipline on the team to create better scalability inside the product. It does do that. That's why we do them. That's why we don't just do TPC results, and we work with the other ISVs to make sure that we're scaling well there. Lots of important new features. We get this quality message. Quality equals reliability, which makes you happy and allows you to build new apps, not run around fussing with existing apps. And SQL Server 2000 is on schedule to ship this summer, and I'm very proud of the release that will come out this summer. I believe this is my last slide, roadmap. I just want to say that we're not going anywhere. I've been with SQL Server for 6 years. The team is excited. It's invigorated. Our turnover is, next nothing in essence. We're building a great product. It's successful in the marketplace. We're not going to stop. We appreciate your business. We're going to drive this business forward, and we're going to be the best database on the planet. I mean, that absolutely is what we're headed to do. My commitments, I've showed this slide to you every time. It was a slightly different version. We changed things based on market conditions. 7.0 out there, Shiloh or SQL Server 2000. I've just given you the details on that. Yukon, the next release, I'm not going to say when it's going to ship. I don't know yet. I got to ship this one first. But shared nothing clusters, you've seen my commitment today based on that. Language independent store procedures. We know you want to program the server in more languages than just T-SQL, and we're going to pursue that actively. Complex record support. Table within a table, XML, deep embedding, more sophisticated programming environments, more along the lines of object programming. Absolutely, we're going to provide that. More work in terms of self-managing, a key design point for us. I'm going to pound on that and keep pushing it forward. Fully integrated data warehousing, self-tuning database, absolutely. Again, through the entire talk, you've seen that. So in closing, thank you. Thank you for your business. We're working our tail off to make it a great product. These sessions are important. We learn a lot. You learn a lot. Don't go out of a session unless you've learned 3 or 4 or 5 good things that you can take back and make a difference in your development. I thank you for your business. I hope you have a great conference.